Compound angles, double angles. Do you see compound angles? Maybe this is a compound angle, don't you? Okay, but now I've said to you that the compound angles and double angles are the only new working tree this year. But that's everywhere now. Because didn't you do identities left-hand side, right-hand side in grade 11? Yes. But now inside of them, there will be compound angles and double angles. Inside of your Pythagoras and cast butterfly sums, there's going to become double angles and compound angles. In your K sums, there can be compound angles and double angles now. Everywhere. So you're going to be having to identify this from the start. Okay, so sum says left-hand side equal to right-hand side, so split it up. You cannot take that -1 across to the other side, making it a +1, because it's not an equation. You've got to prove it's the same. So, let's have a look at what's happening here. Is this not maybe a double angle formula?
It's not squared.
It's not squared, exactly. Guys, it's right or it's wrong. If it was 2 cos square -1, it could have been double angle of that cos double angle, so cos 2x. But if it's not cos half x. There's no such a rule. So let's have a look at this side. So that side, I don't think I can do anything. But on this side, what is there to do? Maybe something with a compound angle and a double angle. Now I've already said, isn't this maybe a compound angle? But it's 540. 540. Subtract 360. How can I just do that? Because if it was 540 minus x and I can subtract 360, the reason for that is your graphs, your sin and your cos graphs go on forever doing the same thing until forever. So if you can minus 360 and minus 360 and minus 360, you're going to get back to between 0 and 360. That's why you can just subtract 360. Because the same pattern will recur again and again. So even if you're at 2000 and something and you subtract 360 all the time, you're going to get back to the first 360 again. Okay? So how would that look if I did that here?
180
180?
minus x.
Is that good news for me? Yes, absolutely it's good news for me. 360. Subtracted from it. Gives me 180. What is this? It's a proof sum. Yes. Reduction formula. Poof. Gone is the 180 minus. Could I do it with compound angles? Yes, but please don't do that to yourself or to the marker. Please. Because it is cos, sin, sin. And you can go cos 180 and sin 180 and special angles, etc. But you're still going to get back to. Now please let's reduce it. Go poof, and what happens? It's just cos. Second quadrant, negative. And that one's also a negative. This one stays a 1. Nothing happening here. It's just that reduction formula. I also told you, please don't write plus now. Show me that it was a minus. This one reduced to a minus. The next step, it will be
a plus.
And I'm happy with that. Are you with me?
Yeah.
Show me everything. So you're showing me that you threw away the 360. You're showing me that you can do the reduction formula. Okay, let's get back to the top. Is there not maybe a compound or a double angle at the top somewhere?
I feel like there's a double angle.
Wait. With 2 sin square. Right? But wait, you get cos. How? Has to be 1 or 2 cos square minus 1 or even just cos square minus sin square. Now, where do you get this from? If you're struggling, formula sheet. But can you see what I'm talking about here? That is going to be a double angle. And all of them get reduced back to cos double angle, cos 2x. It's true, but I'm not going to do it. Okay. If I do that and I make that cos 2x, I'm not going to do it. So don't write it. If I do that, then the rest of the sum is plus cos x plus 1. And now what? I'm trying to find this side equal to 2. cos x minus 1. What does the angle look like? Just x. This is not a compound angle or a double angle. If it was double, it should have had a square. I can't just put a square there myself. It's not an equation, you can't make things happen. So this is not a double angle. So I need it to be in single angle state. So it doesn't help me to go to 2x, because what I just wrote there true? It's true, but what do you want to do with it? Constantly I'm going to say, yes, what you wrote there is not wrong, but it's getting you nowhere. Because you need it to simplify to get to something like that. So if you take it to double angles, you're going to have to make it undouble again sometime. Making sense to you what I'm saying? What's written there is not wrong, but it's going nowhere. Okay, so what else then? Now, if I do have that, cos x plus 1, and let's keep it minus sin squared, can I simplify?
I'm thinking there's a
Are you
common-
thinking to cancel out?
No,
I was just going to say think again. Why can't you cancel out?
there's pluses.
So how do I get the pluses and the minuses?
Where'd you take that to?
How?
Factor.
Factorize. Always been the case. And guys, this is the reason why left-hand side, right-hand side identity sums have never been level 1. Not normally. They are normally the higher level. Even the easier ones are level 2. Because it's not just straightforward. Because we're thinking something which isn't wrong, but it's getting me nowhere. So now I'm teaching you to think, where are you headed for this thing? So this bottom thing, I don't think was too bad. But if that's what's at the bottom, then my mind says to me, this is Hans Karlbeck taught me last year, that I must then also, for this thing to be simplified, there had better be that bracket at the top as well. Otherwise, why am I factorizing? Are you with me? How do I get rid of those pluses and minuses? Put them in brackets in factorization so that I can cancel
Out.
Everybody with me on that?
Yes, sir.
So how am I going to do that? Now, let's try and factor, oh no. Not a double angle, because you can't have double and then single and factorize that. Nuh-uh. It has to be the same angle. But if you left it as minus 2 sin squared, then we've got sin squared and cos. Shouldn't we have all cos or all sin to be able to factorize? Alright, so now how am I going to do that, guys? Turn it into cos. How?
By p-cut?
Okay, please don't just say sin x is cos 90 minus x. Is that true?
No.
Is it true? Yes. Is sin x equal to cos 90 minus x? It's true, right? But it's not going to get you anywhere again. Because if you have, for instance, is it true? Well, it's not completely true because the minus 2 is not always also there. But what I've just written there is a truth, getting me nowhere. Are you with me? So there's a lot of things that might pop into your head to do, but it's getting you nowhere. Because how are you going to factorize that if the one angle is 90 minus x and the one angle is x? We're needing to factorize most probably quadratic trinomials, which we're aiming for. But how am I going to get that right? You did say, let's change this into cos, but how? No. Because of the grade 11 identity, square identity. You can change sin square into what? 1 minus cos square. So this minus 2 will still be minus 2, but the sin square will be 1 minus cos square. Guys, it doesn't jump out at you and say, listen, do you see it? Do you see it? You don't see it unless you look for it. Unless you look where you're aiming and that you're wanting to have those brackets be the same. Because that's the only way that you're going to simplify, is that the brackets are the same. And you can't get them the same if the one was sin. And you can't change the cos into a sin unless you go 90 minus, which is not going to work for us. But the square identity always helps me to get to the square identity of cos. You with me here? What's this going to become then? So we have minus 2 plus 2 cos squared plus cos plus 1. Ready? And how can that simplify?
Minus 1.
You can add them. And that's the only ones that you can add. But what is this thing to factorize? It's a trinomial. By no means level 1. By no means level 1. Okay, so 2 cos squared, then the cos, then the number, so that it's in the correct order, descending so that you can factorize. But now I've already given you a hint. If this is 1 plus cos, I would like the top to be 1 plus cos as well, but it bothers me a little bit that the cos is at the back. Should it bother me?
No.
Did I change it by timing with a negative? Because 1 plus cos and cos plus 1 is the same. The reason being, if I factorize that, it's going to be something with a cos in the beginning and something with a number at the back. So we know that we're aiming for cos x plus 1. It's like we showed you, especially with those difficult exponents with fractions, when you had to factorize them, you actually let yourself be led by the bottom one. It has to. It has to cancel out, otherwise why are you doing it? Now if you got the top one, you can put the other one right, because cos x times what is going to give you 2 cos x? 2 cos squared. 2 cos. And please don't just write 2 cos. It's 2 cos x everywhere. And then the number that must be there at the back to get me the minus 1 must be minus 1. But it's actually a quadratic trinomial that you can do with your calculator. Just remember that this is now ax squared bx plus c. Ooh, but with the causes. Okay, so it's just more difficult because of the level of sum. And then when I got there, I'm done. What am I trying to do here? Get it to 2 cos x minus 1, and that's what's going to be left. And even if you now told me it's equal to the right-hand side, I'll give you the marks because I can see it cancelling out and being equal to the right-hand side. Maybe I would have liked it a little bit better if you just said 2 cos x minus 1, and that's equal to the right-hand side. How many marks?
4.
Maybe 5, I don't know. It's quite difficult. You had to do the reduction of 360 and the reduction formula there again, maybe just 1, because it wasn't that difficult. But then going for this one, and we were thinking, contemplating a whole lot of other things, until we came to why would we want to take it to cos, so that you can factorize and cancel out. How much practice does one need for this? Okay. Now you have time now from now until the June exam, well the May exam, when you do your mid-year exam. From now to then you can practice a lot of them. But if you have to practice just the day or 2 before, it's not going to help you to do 200 of these. What about the rest of the stuff? So now's the time to go and practice them as much as you can. Because the day before the test, exam, there's no time to go and do 10 or 20 of these. You've got to get into the practice. Okay, I'm going to give you this one for homework, for classwork, and as far as we can get with it. But you have to give me an idea. What do you think we're going to do here? Left-hand side, right-hand side. Is there something that jumps out at you to do?
Double.
Compound angles, do you agree? But that's going to mean expanding and expanding. And those 2 answers, oi. And then most probably what's going to happen, because it's multiplication, it's going to be FOIL. With those horrible things, yes, so be it. Maybe we're lucky on the right-hand side and we can simplify a little bit. Can we simplify something here? Double angle? 1 minus n squared? Squared? Cos squared, it's grade 11. So that's going to be cos squared of x minus sin squared. Isn't that a double angle? Say no. Why?
Angles are not the same.
The angles are not the same. If they were both x, then there was a double angle. You've got to look carefully and know what the actual rule says. So, okay, that's at least something. Hopefully we'll get there by this. But that is not a double angle. That's the point I want to stress. Now, even if you just did that, you got a mark for sure. Because you did something with an identity. You're going to get marks for expanding and for expanding. And then you must carefully go and do the FOIL and see what comes out of there. Because even I can't look at the sum and say, oh yes, step 1, step 2, step 10, yes, I've got it. Can't. Because of identities being so intertwined. Sometimes you go from sin to cause, and sometimes you go from tan to sin over cause. You can't see it as you look at it like that. You have to take some time. There's your 2 homework sums, number 3 and number 4.